Hello, good morning, everyone. My name is Samuel at Gyasi Otabir, and I'm a final year student in electrical engineering. So, in today's topic, we'll be talking about AI in airport. Are we safe enough? So, think of it for a while. Now, before we begin, I want to give you guys some statistics. So, on an average in a day, there's about 2.6 million people that use the airport, and then there's about 4.9 million baggages that go through the airport, and there's 3,356 anomaly objects. Anomaly objects are things that are not wanted in an airplane or on an airport. And in the year 2022, there's an estimated of 7% increase in the number of anomaly and the daily average passengers. And the normal way of checking the stuff is using the officer to identify which anomaly is in the bag. So 50% of the time, the officer might be tired, and 50% of the time, it affects the accuracy due to the tiredness of the officer checking. Now, so the objectives of this work is we want to develop a threat object detection using convolutional neural network, and we want to analyze the key effect of the key parameters of the trained framework, and want to investigate the accuracy of the developed framework. So we'll be using CNN. So CNN is actually a neural network that is best optimized for image related stuff, and it was founded by Yang, a French scientist. So CNN has several layers. We have the input layer, hidden and out layer. The image below shows a sample of how CNN works. So we have our input and several layers going on. Now, so the type of CNN we'll be using is known as yellow V5s. The reason why I'm using yellow V5 because it's a single stage object detector, and the activation function that is used is RealU and Sigmod. And then there's two types of optimization function, SGD and ADM. And the cost or loss function is the BCAL or focal loss. Then the head and the backbone and neck is using advanced and current technology. We have the dense prediction, cross partial path network, and then the path aggregate network for our neck. So these are the items we want to detect in our baggage. We want to detect all of this gun to handcuffs. All of these things are not needed in a bag. So we want to detect that. And then before we build our model, we want to optimize our hyperparameters. We want to optimize learning rate, momentum, weight, decay, and everything. So after we optimize it, that's where we put it in our trained model. So this example of the graph that we got from training our model for 200 epochs. So you can see our accuracy and recall and precision is actually going very high. And then we are attaining about 90% of precision in all classes. And then we had a recall is actually going down. We are attaining a recall that is about 20% going down there about. So these are conversion metrics. As you can see, our model is predicting what is supposed to be predicted accurately very well, and this is the training and validation one. So overall, we estimated receive an MAP of 89.90 for our main accuracy position, and our position is also about 80%, and recall is going down to about 70%. So always in the model, we want our precision to be higher than recall. So as you can see, our recall is going down as our position is going up. So the precision and recall and accuracy recorded of the individual classes can be seen in this slide where we have the pattern, bullet, and all of it recorded down here. So we have a bullet, we can identify a bullet with 94.94% accuracy, a pattern with 89.9%, and hammer for 93%, and scissors for 90%. And this we compared our model with Yellow V3 and MobileNet SSD2, and Yellow V5 still had a very great MAP at 0.5. Now our model is able to perform well in real-time performance when it's able to identify the items with a speed of 0.5 milliseconds and is able to pre-process with 97.8 milliseconds. So thank you so much for my presentation. If you have any question, you may please ask me.